Okay. So in our last class, we had discussed about the Terraform workspace. Okay. And we saw what is the usage of the workspace and what's the benefit we'll get out of that. Also, we saw a demo like how we can create a different, that is what the small demo, whatever I just showed you, that you have to do by yourself, like something extra, right? Something extra practice you need to do, and something you have to think logically what you want to do, and then write the code based on the things whatever we are learning. That is the motto, right? So today, what I'm going to tell you three advanced and three most important things. One is the depends on. You may get questions under that. What is this depends on? In Terraform, this is a meta tag. Depends on is a meta tag that allows you to specify dependencies between resource and modules. So this is most important. What it does, it gives dependency between resources and modules, right? Dependencies between resources and modules. Suppose you want particular resource to be created once the other module has been executed. So this particular resource will be dependent on that particular module or that particular resource. So that's a dependency. For example, here we have an example. Suppose we have an EC2 instance, and that depends on a specific bucket. So using depends on tag allows Terraform to create or destroy resources correctly. So if you want to create a server, and before creating server, you make sure that a specific bucket has been also created. Then you can go with this depends on. Okay. And what else it says? When Terraform sees the depends on module, it first create or kill the bucket before performing the action. What it says, using depends on tag, what is it? If you have EC2 instance that depends on a bucket, that means EC2 instance is dependent on bucket. So that what will happen? It will first create the bucket and then create the instance. Okay. Similarly, what else it says? Module support for depends on was added in Terraform version 1.3. Earlier, it was not there. So from 0.13 to prior version of Terraform, if you're using, then you'll get this particular option, depends on. Okay. So here is a snippet. Here is a code. If you see here, we have this bucket.tf. What it do? This resources, right? This resource AWS underscore S3 underscore bucket. You guys very well know how to get this resource, right? From the resource documentation, right? From Terraform. So this is AWS underscore S3 underscore bucket, and this is a bucket. This is the resource name, what we are going to create, a test bucket. And it's a bucket. Here is the bucket name. Okay. This is the bucket will be created. And this is a tag. This is snippet will create the tag. Now what will happen? First, what it will do, it will create this my-tf-test bucket. Then it will execute this particular resource. Then it will execute this particular resource block. So what it does, this resource block, it is just creating one instance. It's just creating an instance. But here we have to write this particular tag depends underscore on. Depends underscore on AWS underscore S3 underscore bucket, which is nothing, this one, right? Dot test bucket, name of this resource block. This is the name of the resource block. So what will happen? It will get first this bucket.tf execute, means this bucket gets created, and then it will execute this particular resource block. Okay, that is what it does. And this is very important to know this particular tag. Okay, guys, if you want to particular resource, simple term, I just want to tell you, simple statement. If you want a particular resource to be executed first, followed by another one, then you can use depends on. Very simple, nothing much there, right? So, and the next one which I'm going to tell you is Terraform Backend. So what is this Terraform Backend? Okay. So far, whatever TF state file, Terraform state files, we have executed. So when a state file will create, guys, when you execute Terraform apply, right? When you execute the infrastructure code, that time our state file will be generated. So what the state file contains? The state file contains the infrastructure, the current state, all informations, the current state, right? We had discussed about the state, current state and desired state. If you remember, in our previous classes, we had discussed about the current state and desired state, right? The current state, which is contains in the state file, and the desired state, which is given in the configuration file, .tf file, right? So the current state file, the state file, whatever we have done so far, when we execute, what will happen? It will generate that state file in the local machine, on your local machine, right? So if I just go to the machine here, if I just go to this resource demo, we'll see here our state file, right? Terraform.tf state, Terraform.tf state. This tf state file is available on the local on my machine where the Terraform command has been executed. But why we need this backend? What is the benefit, right? See, backends primarily determine where your Terraform stores its state. So let me just explain you. Locally, suppose you are working, multiple team members working on the project in your team. And if you use locally to store the Terraform state file, your team member cannot work on the same code again because it will conflict the things, because you'll not know what are the changes, what is the current state, what are the changes being made. All right. To overcome this problem, we can keep this state file in a backend, in a server where we can, anyone in your team can get that state file while executing the Terraform infrastructure code. What is such? By default, Terraform implicitly uses backend called local. By default, it implicitly uses a backend called local. That is why it stores all these things in the local machine to store the local file on the disk. Storing the state file in the local laptop will not allow collaboration. This collaboration, which is the term being used mostly in the DevOps. So DevOps is nothing but a collaboration between the development and operations team. Within the team, not only the development operations, within all stakeholders, all the team, we are collaboratively working, right? So if we keep all the things in our local machine, how collaborations will happen? Because other member in your team cannot get it, right? So that's why we are using the backend to store remote backend. That's called a remote backend. By default, it is the local backend. By default, it is local backend, right? So here is the architecture. What we can see here, the TF file, normally what happens? Our TF file gets stored on the repository, right? Project repository in the GitHub or GitLab, whatever you are using. That is the TF file, Terraform files, configuration file will be stored on the Git repo. However, the TF state file, we can store in a central backend. In a central backend. So what is such? The Terraform code is stored in a central Git repository, and the state file is stored in a central backend. So here, if you see, Terraform supports multiple backends that allows remote service related operations. So by default, we saw Terraform provides local, right? Terraform provides local to store local backend. By default, backend is the local, which stores the file on the disk where you execute it. But in the backend, we are going to use will be the remote backend. For the remote backend, we can use these are the popular backends who provides it. These are the popular backends. Okay, so these popular backends, one is S3, AWS S3, that is the nothing but our bucket, right? And this is the console, Azure RM, Kubernetes, HTTP, etcd. So these are the popular backends being used. So accessing states in a remote service generally requires some kind of access credentials. And some backends act like plain remote disks for state files. Others support locking the state while operations are being performed, which helps prevent conflicts and inconsistencies. What is it? Some backends act like plain remote disks for state files. Others support locking the state while operations are being performed, which helps prevent conflicts. Suppose one person is doing some changes, right? If you have kept, what is the, okay. So before going learning the backend, we should understand the Terraform state locking mechanism. So what happened, guys? Whenever we execute the Terraform apply, what happened? Terraform will in the backend, what it will do, it will lock the file and then do the changes. Okay, lock the state file and lock, it will create a lock file and do the infrastructure changes. Okay. If I am executing the command on my machine, it will lock where? It will keep the lock under my local laptop, my local machine. But if Alvin is executing the same command, he got it from the remote repository, GitHub repository, and executed from his laptop. How Terraform will know that whatever the changes Ranjit is doing, it will not known to the Alvin, right? What will happen? When I execute the command and the same time, Alvin also will try to change something, it will conflict, it will throw errors. It will not work. Even whatever the changes I have done, the state file will not be available to Alvin because it is locally available on my laptop, right? It will be a problem. If the same thing being stored in a central repository, backend repository, what will happen? Both Ranjit and Alvin will be connected to the central repository. So state file, whatever I execute, it will be stored under S3, or whatever Alvin executed, it will get from S3 and it will be executed. So consistency will be there, right? That is what it says. If we don't perform the backend remote things, it will provide give the conflict and inconsistencies. So how we can do that? S3 as a backend. I'm just showing one example here. S3 as a backend. So here, so we have to use a tag called S3 backend. Okay, so we have to use this particular S3 backend. You have to use Terraform backend. The tag, the argument or like this backend, you have to the block, you have to use backend S3, and you have to give the bucket name. Okay, which bucket you want to create as your S3, and here key. This is the folder. This is the state file which will be stored, and this is the region, right? And here what says, to access the AWS bucket, we need to configure the credentials first. And that is most important, guys, to do that. So let me quickly do a demo for that so that you can easily understand, right? So after that, what we'll do, we'll talk about the Terraform log file. Okay, first let's finish the Terraform state log file. What is this being used? And then we'll just do a demo on that. Okay. So what is the log file? I was just telling you just before, right? What is this state log file? So Terraform statefile lock is most important. Why? What it says, whenever we are performing a write operation, Terraform will log the state file. That is what I was telling, right? Terraform will log the state file. So this is very important, as otherwise during your ongoing Terraform apply operations, if others also try for the same, it can corrupt the state file, right? It can corrupt the state file. That is why whenever Terraform apply we execute, it will first lock the state file so that it cannot be modified by other resources. So when the Terraform execution process is going on, it will create a log file called, this is the format, .terraform.tfstate.log.info. Okay, so this is the log file it will create. After the Terraform apply is complete, it will remove out this log file immediately after the Terraform apply is executions done. During executions, Terraform apply executions, no one can do that. See here, I have just given small snippet here with Soch. If I just maximize a little bit, I just captured it while I'm executing something. I captured this log to demonstrate you, to show you. If already you have done Terraform apply and it's under process, if you do some another one, what it says, error acquiring state log file. So guys, this is a task for you. I'm just giving you. Whenever I'll just tell you how you have to do that. Just create any 2 or 3 resources and just apply Terraform. Just apply Terraform. Do Terraform apply, and immediately after on the other window terminal, you just do Terraform plan. You'll see what is the error you are getting. Okay, and same time you can see that same folder if you do ls-la. Okay, ls-la, you will get the hidden file, right? This dot means this is the hidden file. Okay, hidden file, you'll get it, and you'll see there will be a log available. Okay, so this is what the log dodge. Now let's move on and work on this Terraform backend, right? Let me just see if I have already some code is written for backend. I can just get it there. Terraform backend. Remote backend. Okay. So here is the code. It's very simple. That is what the code I have written it there, right? Terraform demo MB, and that is one instance file which will create the instances. Okay, and here provider. This is the provider block with the key. Okay, so what I'm going to do, let's use this particular code snippet to do the demonstration. Okay, what I'm going to do, let's create one directory which will be clear, right? I'll just give it as remote backend demo, backend, something like this. So remote backend, mkdir, right? There is a typo. Okay, go to this directory. Now what I need first thing is to create a provider block, right? So let's go ahead, create a provider.tf file. So for provider, let me just copy these things. And here the version I'm using 4.11. The previous provider, whatever, it was 5.10, right? 5.10. provider, but I don't need this key there. These keys might have been expired because this is a very old code. Okay, provider, I'm using AWS, and this is the region. The key already set off already in my local machine, so no need of the keys, right? Provider is done now, ready. Now let's move on to the EC2 instances. So here I'll little explain you what is this EC2 instances and EC2.tf. Put this code, but here you need to understand. Here I'm using these particular things. What is this? Data AWS underscore AMI. Okay. Using the, what is this, guys? You remember, we had discussed about the data source, right? We had the data source, right? If I just go to this particular Terraform, I already have told you all this, okay? Let's go to the Terraform and ducks. Sorry. I'll go to registry.terraform. Oops. Registry.terraform. Documentations. So go to the AMI sections, right? Go to the AMI. I'll just show you how you have to do that. Go to the AMI sections. Mission run. AWS underscore AMI. Just search for AWS underscore AMI. Okay. So here where it will be AWS underscore AMI. Resources. Go a little down. AWS underscore AMI. This is IAM part. It's better to it's taking more time. So it will be under, let's check C2 cloud compute, right? So guys, you can search also same time. So Elastic compute cloud. Okay. So here it is in the EC2 section. It is AWS underscore AMI. As I was telling guys, right? So what happens here, guys? We have two blocks, right? Resource block and here data source block. Data source block. We already have discussed about the data source block, right? It just gets it fetch the information and give act as the input to the resource block, right? Same thing for AWS underscore AMI, right? You can see it uses data, and this is the data source name AWS underscore AMI. So what it does in this code here, this particular snippet, what it does, it just fetching the image details, fetching the image name. What will happen here? What it will do? It will get with, see the command with AWS AMI, we're using most recent true owner Amazon. That means I'm going to get Amazon EC2 instance, Amazon AMI, Amazon AMI. If you want to get Ubuntu or CentOS AMI, you have to provide Ubuntu or CentOS there or Windows here. In the filter option, name of that one, and values. What is the value? You have to filter it out. So mostly Amazon AMI having this keyword. Similarly, you have to find it out for Ubuntu, what will be the keyword, for CentOS, what will be the keyword. Here it will have some examples. See, filter options there, right? Values you can give us EBS, SVM, or whatever, right? See? Okay. So why we need this particular data source, guys? Sometimes what happens, not sometimes, most of the time, guys, we never work the inbuilt image from the AWS or any cloud provider. What we do, we get our own image built. We had seen this information in discussed in details in our Docker classes, right? we created our own image file, and from that image file, we created the container. Similarly, here also we have to create our own image, right? Same thing for own image, we have to write it here, self, owners, self, like created by us, okay? And that you have stored on the AWS. That you have to use the fill. And here is the arguments. You have to go through this argument and these attributes, whatever the attributes there. Now, if I just go here, I have used this filter options, name and value should be like this. And if you use name something else, and value will be EVS, right? And here in the resource AWS underscore instance block, which will create the resources, right? AMI, this is what the data we are fetching from the data source and getting it from inputting this value, whatever fetching from here to this AMI argument, right? What is this AMI parameter we are given? Data dot AWS underscore AMI. What is this data? This data is nothing but this data. AWS underscore AMI, AWS underscore AMI. And this is app underscore AMI is the name of this data source block, and the ID. What is this ID? This is the attribute of what? Of this data source. If I just see here, this attribute of this particular AWS AMI, right? AWS data source AWS AMI. If I just go to the attribute section here, attribute, will find ID will be there, one of the attribute, okay? Where it is. Oh, sorry, it's not the AMI data source. It is the AWS underscore instance, because what we are using, we are into AWS underscore instance, right? So if I just go to AWS underscore instance, there will be one attribute called ID, right? If I just go there, we find the attribute. These are the attributes, sections, right? Okay, here attribute, come down, we'll find ID somewhere, right? What is this? Here ID. ID is the launch of that. It's the template. Okay, this template, whatever the template, whatever we get it, we'll get it the ID option here. Okay, so if I just go here, what it will fetch? It will fetch the image ID of this one. Okay, so we got all this information. So we got this image ID, and it will be gets created. Now, what do we need? Our EC2.instance is created. Now, what we can do? We can just go ahead and create the backend. Okay, let's go ahead and give this as backend.pf. Okay, just create backend.pf. So what will happen here? In this backend.pf, let's copy this code, backend code. So what is here? We used, see, this is what you have to write in the backend section. It should be under the Terraform block here. Under this Terraform, you have to write the backend block, right? This backend block. And this backend block, you have to just use this particular arguments and all. What is this? Bucket, Terraform, bucket. So I think this kind of bucket will not be available. Now what I'm going to do, let's go ahead and create a bucket. Create a bucket. Okay, manually I'm going to create a bucket. The same thing, you can write the code to create a bucket, right? Code to create a bucket. So what is the code we can create the bucket? Okay, now let me show you that one also, right? In our previous slide, right, I showed you depends on this kind of things, right? Resource, AWS things, and create the bucket, right? Let me use this code to create the bucket here, right? Okay. So what happened here? I've just used AWS. Okay, guys, this will cause lots of problem. Let me write something here. So what I do, you have to just use the resource. Okay, AWS underscore S3 underscore bucket. Done. Test any bucket. So the bucket name, any I can suppose test bucket, something that would be there. So here, bucket, I'll give it as, suppose the bucket name. What bucket name for backend we are going to use? It was given as, for backend, it was given as Terraform demo -mb, right? Let's copy this one. You can give any name. I just gave it, but you can give any name, right? So let's put it there. Terraform demo. This is the bucket name. Okay. Now we can given any tag. This is optional, but if you want to put a tag, you can just give the tag, or else it's fine. Okay. Let's put the tags. Not a problem. Tags. Name equal to my anything you can give. Okay. My bucket. It will be environment. This is just a tag. Okay. And env, I can give env patch is a key value pair, right? Dev environment or test environment, whatever you can test environment. Let's close this tag block. Done. What will happen? It will create the bucket called Terraform demo -mb. Right? Let me delete it out. Done. So our bucket also created. Okay. Now, what we'll do, guys? Our bucket is now created. Now apply depends on there. Now apply depends on there. So where we have to write the depends on, guys? Suppose we want our EC2 to be created, sorry, bucket to be created before EC2 gets created, right? First bucket has to be created, then EC2 instances has to be created. So what we have to do? In the EC2 instances, we have to write the depends on things, right? So where we have to write the depends on tag under the resource block of AWS underscore instance. Okay. So if I go to the depends on here, see, simply keyword we have to write the same thing, right? We can copy. Let's copy this. No need to copy it. It will cause problem. So you can simply write the depends on. Okay. Simply write the depends on. So what is that? Depends underscore on equal to, right? What it says? Within the square bracket, we have to give the bucket and the bucket name, right? Within the square bracket, get the bucket name. What is the resource? AWS underscore S3 underscore bucket. This is the resource name. Dot what was the bucket name? It was given as also test bucket, right? Test bucket. So let's verify this. Yes, it was given test bucket. This is the resource name and bucket. I just created the depends on. Okay. Now everything created, we created the depends on, we created the backend, and everything is ready. So what will happen first? First, it will create a bucket, then EC2 instances, and the backend will be stored there, right? Now let's execute. So first we have to use Terraform init. It is the new folder and we are creating. So first, okay, fail to get existing workspace S3 bucket does not exist. Bucket does not exist. Okay. Now what do we do? Before executing the backend, our bucket should be created. Our bucket should be created, right? So what we can do, we can simply just first execute the bucket and then we'll execute the backend and all, right? So what we can do, I can just simply execute. Let me rename. Because apart from these extensions, only TF extensions it will be executed, other extensions it will not execute, right? So I'm just renaming with a different execute so that it will not execute. Now, if I do Terraform init, it will initialize. Where is iTerraform? In provider block. Okay. VI provider block. Okay, here extra I is there. Now let's execute again. Terraform. You know, other command is to validate, right? To validate the code, whether the code is correct or not, right? So you can do validate also, no problem. So use init. So it's just initializing the plugin 4.10 AWS plugin we are going to use, right? Okay. Now it is initialized. Let's first create the bucket Terraform plan. Let's see if everything is correct. See here, okay, here is creating a log file, right? Now, yeah, this is the bucket and this is the bucket name. It will get created, right? Just do Terraform apply. Yes. Okay, so our bucket has now been created, right? Let's rename this file back to the original, okay? And C2 and is that backend? Backend. Okay. Okay. Now just do Terraform plan. Terraform plan init is not required. Please run backend initialization required. Okay. Remember, whenever you use backend, that should be initialization required. Again, another thing, because we added backend there, so we have to first initialize it. Okay, Terraform init. So it is now initializing the backend. Okay, entered value. Yes. Successfully configured the backend as S3. Now, the state files will not be stored in local. It will be stored in the S3 environment. It will be stored in the S3 environment. Okay. So what we can do now, let's do Terraform plan. There is error. What is it? Test token has not been declared in the root module. Test bucket has not been declared in the root module. Why? Anyway, dependency is not required because already the bucket is created, right? Bucket is already created. Before executing the backend, the bucket should be created first, right? So dependency is no point of using the dependency because already the bucket is there, right? So leave it. Now use Terraform plan. So it will just create. Now execute Terraform apply. let's see the log, what is doing, okay? Just okay, so now it's done. Now let's do LSF and LRT. Let's see what is giving us. Okay. See, we don't have any Terraform state file here. It is 0 in size. The backup, which we created the bucket, right? That is the backup. There's nothing worry about this. Only we see here, we don't have this Terraform state file available here. So where it is now, if we go to our S3 bucket, right? Let's go to our S3 bucket. See, we have this Terraform demo -mb available. Terraform demo -mb, right? If I just click this, see, we have a state demo folder, right? So what is this folder? If I just do cat backend, right? See, we have given a folder name, right? State demo, right? We have created this. And what happens? If I click there, we have this state file with size 8.7 KB, right? This file is now kept it here, Terraform EF. So if Alvin will use the backend with the same bucket, then he can get this Terraform state file in his laptop and he can work on the same code. All the changes can be done. So it's clear, guys, very clear. The same time, you can use any of the backend available in the market. These are the popular S3 console, Azure M, Kubernetes, HTTP, etcd. If you're going to use AWS, then S3 will be the easiest one. And to use S3, you can use console, Azure M as your choice, as your requirement. Okay. That's all about the state log, backend, and definition. So let's move on to the project. Let's move on to the project. The entire project, okay, whatever we are going to learn now, just focus on that, what I'm going to tell you and what you're going to learn. So far, everything, all the things we have learned from the Terraform, right? What I'm going to tell you today, the main project will be on the three-tier architecture, okay? AWS three-tier architecture, that's called. And definitely you'll get questions on this. Have you worked on any three-tier architecture? Have you created anything, or have you have ideas on that? So you can just tell them and explain them what is that and how we can achieve it, right? So let me go to that and explain you what is a three-tier architecture and what is used for, okay? What is it is used for. Now, the three-tier architecture is the most popular implementations of multi-tier architecture of consists of a single presentation tier, okay? Consists of single presentation tier, logic tier, and data tier. Here you can see we have a client that is a presentation tier. We have a logic, which is the server side, which is the data tier, right? It is viable choice for software projects to be started quickly. But this to achieve this three-tier architecture, okay, I have just kept a diagram here. Okay, let's just come here. I have this diagram here. This is what the project we are going to do. This is a design which I'm going to show you. So what we have done so far, anything we have done, any things we created in our own VPC, in our default VPC of the AWS account. Now here in this project, we are going to create our own VPC, custom VPC using Terraform. This entire things will be our VPC. This is virtual private cloud, nothing but virtual. This is kind of our VPN, right? Virtual private network. Similarly, we have created a virtual private cloud, which will be our infrastructure, our network, own network. And in our own network, we are going to set up the details, public subnet, private subnets, and we have to create our EC2 instances there. So how the design is here, we have this EC2 instance here, right? You can see we have this EC2 instance. And this EC2 instance, we have a security group, we have a NAT gateway, we have all this in the public subnet. So what is this? We'll have two public subnet where our EC2 instances will be kept in the public subnet. Two EC2 instances will be in public subnet. One EC2 instances will be in the private subnet. So normally what happened, the design, the applications always being kept in the public subnet. The applications which are public facing, right? The applications which are public facing can be kept in the public subnet, can be accessible through internet. But normally the database, the DB server, right? We keep it in a private subnet, in the private area where there will be no internet access, no direct internet access, no direct internet access to the internet gateway. Okay, so how we can achieve this? Because in a database server, if we'll not get any internet access, how will update, upgrade, or install something in our DB server? At least we need the internet connection. We need an internet connection, right? So how we'll get it? Using this NAT gateway, we are going to achieve the internet to our private subnet. So what we have to create? We have to create a VPC. We have to create 3 subnets. We have to create 3 EC2 instances. We have to create security groups. We have to create route table, right? Through main route table, custom route table. We'll have internet. We'll create one internet gateway. Okay. We'll create a load balancer, right? All these things I'll show you how we can create in our Terraform, Okay. So I have, this is what the flow, okay? What happened? This public subnet will directly connect to the custom route table, and through it will go to the internet, right? Through it will go to the internet, right? Through it will go to the internet here. And here the private one, through NAT gateway, it will go to the main route table, and through main route table, it will come to the internet gateway. And through the internet gateway, we'll have one application load balancer will be there, which the user will connect to our applications through the load balancer. Okay, this is what the entire project we are going to do. And what are the things will be created? These resources will be created. We'll have one custom VPC, 2 subnets, public, 1 subnet, private, 2 EC2 instances, okay, and the security groups, elastic IP will be required, okay, NAT gateway will be created, internet gateway will be created, route table will be created, application load balancer will be created, and we'll have this Apache web server and MySQL DB. Okay, now let's see what the code we have to write for this. The entire project, guys, I have kept in my repo as public, right? You can just fork this one and just started working on this one. But let me explain you each and everything. Okay, first, as per the diagram, let's move on as per this diagram. So first, what we need to create the BPC, right? So for custom BPC, what you have to do, I have just created one file called bpc.tf. Okay, we have this bpc.ts. It's very simple, guys. Nothing you have to worry about. You just have to get this, how to write the BPC. So how you'll get it, guys? I always tell you from the very beginning also, whatever the code I'm giving to you, you just don't copy paste and don't clone it and start working. Just keep it as a reference. Write your own code in keyboard. Open any notepad or any editor, any good editor, development editor, or direct in a VIE. Just write your own code. For reference, keep these things, but don't directly copy paste or directly clone it and start working. That is, it will be very easy because everything will be ready. You have to just clone it and execute the command. It may work for you, right? But there you'll not learn anything. Okay, so you'll learn once you write your own code. Okay, once you do whatever I have done, and the rest of the times you do by your own, get some logic, whatever. See the design, whatever I have given it here, you might need something to twist it, right? To get to do it more, add more resources here. Okay, make it something better, right? So you can add it and just work. Just never be settled whatever I am delivering to you. Try to do more by yourself. Okay, so this is very simple. You know very well where to get these resources from the documentations, right? Go to the VPC resource block and there you'll find it. So what happened here on the resource block, I have just created very simple resource block for your project. I have created a CIDR block. This argument, you have to find it out there, and given 10.0.0/16. This is the network CIDR block for my VPC. So once the VPC is created, what I need this 2, 1 and 2 public subnet to be there, and 1 private subnet. Total 3 subnets will be there, right? So I have to check on the subnet side. So here is the subnet. See what I've done? I have created 2 public subnets. Just see how these 2 public subnets will be written. VPC_ID, right? Here VPC_ID. See here the resource, you know how to get this resource, AWS_subnet. Here I just given as public, the name, right? That's fine. You can give anything. Here VPC_ID. How we get it? AWS_VPC .main.id. .main.id, right? So what happens here? What is this? If I just go to the VPC section here, we have this AWS_VPC main, right? The same thing is given here, AWS_VPC main, and .id is the attribute. It will fetch the VPC ID. Subnet, when I'm going to create a subnet, right? What happens here? I just created a LAN here, means I created a network. In the network, what are the stops I have to build it or put it? Similarly, I created a LAN, and whatever the house I have to construct, right? I have to think about. Similarly, I just created 2 subnets here, 2 public subnets. How? In this particular network, I need this particular 2 subnets to be created, count 2, and here the CIDR blocks, because subnet has to be there, the CIDR blocks, right? So here the CIDR blocks I have kept in a variable file. So var.CIDR count.index. Okay, so both CIDR block and availability zone has been kept in the variables.tf file. See, in the variables.tf file, it is as list, it is being kept. As list, it is being kept. So what is the things is created? In the variable sections, we have CIDR, AG, right? And two CIDR blocks I have created here, 10.0.1.024 and 2.0./20. Two CIDR for two subnets, public subnets, and two availability zones. Okay, so same things have been called here. So this is the public subnet. For private subnet, I have created with 3. And availability zone I have given directly here 1B. Okay, so this is things. And this is what the data, this is the source, data source block. You can just get it there. So once the subnet is created, so we created public subnets. Now blank house has been created. So in the house, what are the items we need to put it? We have to put the bed, or fridge, right? Washing machine, or whatever things you need, almirah, whatever the things you need to put it on the bed. Same thing in the subnet, whatever you have to put EC2 instance, like you have to put a server, you have to put the required setups there, right? In the subnet. Now I have to go with the EC2 instances. Let's go to the EC2.tf. In this EC2.tf.tf, I have two EC2 instances I have created. Sorry, 3 EC2 instances. Two web EC2 instances, which will be web applications, which will be public facing, And this is where I have used maximum arguments. So far, whatever examples I was giving to you, was everything very minimal argument I was displaying. But this one is the most arguments being used here. AMI, instance type, this is the common, mostly we are using this two. Now we can use key name also being used, subnet ID. Where do you want this to be placed? So you have to provide the subnet ID, whatever is being created in the subnet.tf. Region count.index, it will create the same things. It will create two EC2 instances. Okay, and similarly, after that, what happens here? It is just, I'm just copying this file using file provisioner. This particular key file, I'm just copying to the home directory of the EC2 user. Provisioner block is being used because that will be used to connect some database DB instances. So I have used the provisioner file block. This is what you have to think. You have to get your own idea how you have to achieve whatever your requirement. Okay. Now in the DB resource block, here I have used this DB resource, but subnet being used as private ID, private subnet. Okay, being used as the private subnet. Private subnet is used here. Okay, see, and here the security group is being used, right? The security group. Similarly, in public also will have the security group. So this security group will get it. We have the security sg.tf, which will generate our security group, right? So if I just click it here, it has, see how many security groups it has? Security group for DB, okay, and here security group created for the thing. So all together, this is a task for you. Here I have simply created multiple resources block for the security group to create the security groups. For you, the task is you have to minimize this code. How you will minimize this code? By using the dynamic block. In our dynamic block section, right, we had discussed about how we can dynamically pass the values to create multiple resources. No need to write ingress here once, ingress twice here written for 2 ports, right? And here 2 times written, and here we have written 2 times. 4 times we have written ingress block, right? 4 times we have written the ingress block, which is not required. Which is not required. So what we can create? We can create dynamic block, can create use. But why I have segregated here? I have segregated because I have created 2 security groups for security purposes. One security group being given these 2 ports, another security group is given these 2 ports, 3306 and 22. You can also use dynamic block to add only 1 ingress block, not to add 2 ingress blocks. That's fine. So we have, as per the diagram, we have this particular code and everything is being added there, right? Now we have to consider about this. We got all these things ready, right? Now we'll consider about the, because everything, this particular part is now created. This particular part is now created. Now we'll talk about how we'll go with the internet connections. How we'll set up the internet connections, right? Now we got purchased the land. Now we build the house. Now we put all the items in our house. Now we need internet connection, electricity connections to our house. Similarly, we need now internet connections to our network, to our VPC. How we'll get it? We have to create one internet gateway. We have to create one internet gateway. Let's go ahead. For internet gateway, it will be very simple. One statement will be there, okay? For internet gateway, okay, internet gateway.tf, right? See, it's very simple. Only internet gateway resource block you have to use, and you have to provide where you have to set up the internet gateway, which network, which VPC you have to create, you have to set up there. Done. Internet gateway is created. So once the internet gateway is created here, what do we need? We need, let me clear it out, guys. Okay, so it's clear now. So once the internet has been set up, right? This particular internet has been set up. What we need? We need the internet connections to these particular houses, right? Particular subnets, public subnets, not to private subnet, right? To get to the public subnet, so what do we need? We have to create this, not this particular, not this one. We have to create this custom route table, right? We have to read through this custom route table. We have to give this public subnet internet connection to pass through, right? Now go to the route table here. We have this route table created. This is AWS_route_ table. This is the resource block name. And there you have to create the route table. So in this route table, where you have to route your internet connections, you have to specify the internet gateway. Now, under this route section, you have to specify the internet gateway. So for the CIDR block, you have to use means this is public, right? And internet gateway underscore ID, you have to provide AWS_internet gateway gw.id. This is, you'll get it from the internet gateway, right? Got it? We got this custom route table, right? Now Once this route table is created, now you have to associate this route to the EC2 instances, to the respective EC2 instances, right? That's why you've given here this particular internet gateway, this particular route table is associated with this particular. So whoever has experience on the AWS cloud, they can easily understand. If you have created VPC already, have worked on the VPC manually, then you can easily understand. So let me just show you quickly here. If we just go to the VPC sections, right? Let's go to the VPC section here. Under this VPC section, we have these route tables. See, we have this route tables, right? This route table, we have one VPC, we have 3 subnets, 1 route table and all. If I just go to route tables, these are all default. I have not created anything custom, right? So if I go to this route table, we'll have subnet association. This is what I just associated. This is what I just associated. See, AWS route table association means this route table will get associated to those 2 public subnet. Same thing manually, if you see it here, being associated with this internet gateway. One of the internet gateway, it is associated, and this is the route. This is the route part. But the subnet association, if you see here, we can here these are the subnet associated, right? All these things you can find it here. Same thing, we saw these associations. After this, we have here, see, this is the custom route table, whatever we created. This is for public subnet. But the same time, we have to add the private subnet. I'll talk about this one later. First, let's understand. So now, we, as for the image, as for the diagram, we got the internet through the route table, route to this 2 node. Now, all these things are correct. Now, what we'll do? But this particular EC2 instance, which is in private subnet, does not have internet connection. Now, what we'll do? Doesn't have direct internet connections. So how we'll do? Normally, it should go through the NAT gateway. Network, NAT means network access translator. Network access translator, which will provide internet to the private subnet. Through NAT gateway, we'll connect to the main route table through internet. So this NAT gateway should be placed under public subnet. You cannot keep this NAT gateway in private subnet. It should be kept in the public subnet. Those who are very good in the VPC have already done design. They'll understand it very well. Okay. If not, I'll share a few links of my videos, which I have discussed this entire project on VPC manually, as well as through Terraform code also. Those 2 links I'll share with you. You just go through that, you'll understand. Anything, guys, whatever I say always, before doing automations, you should know very well the manual aspects, manual things, how it is being done, right? Then you can code these things. Otherwise, if you don't know, then how will you code it, right? It will struggle to code, right? So this is the route table. We can see it here. It's been created. And here we now created. Now we have to set up a NAT gateway in the public subnet, right? So if I just go to the NAT gateway sections in the code here, we have this NAT gateway, right? It's very simple, also same NAT gateway. But here the allocation ID, we have allocated one ID, one elastic IP we have allocated. One elastic IP been allocated. So one elastic IP has been allocated to this particular NAT gateway. So what is this elastic IP? You have to create the elastic IP. It's very simple. One resource block, AWS_EIP. That's all. VPC true. Nothing else you have to write. Okay. AWS_EIP. And then my EIP. That's all. Okay. You have to just create it. Now, this elastic IP is created. Once this elastic IP created in the NAT gateway, you have to provide this one, right? So here, what I've used, NAT gateway, allocation ID. This is the elastic IP allocated. Where you want to keep this NAT gateway, subnet ID. I'm using the public subnet here, 01, right? And it is depends on this NAT gateway, depends on the internet gateway. Make sure this internet gateway is created. Okay, to ensure proper ordering, it is recommended to add an explicit dependency on the internet gateway. Because if there is no internet gateway, there's no point of having NAT gateway, right? So internet gateway should be created first. Okay, done. So once it is done, the NAT gateway, now what happens? As for the diagram, we created this NAT gateway. Now we need internet connection from private to NAT gateway. So for that, what we have to do, let's go to there. In the NAT gateway, you find it out, right? So if I just go to the EC2 instances here, right? Down. Here I have just used the subnet ID, private subnet ID, right? And here, security group being added. Nothing has been given related to the NAT gateway. So how this will get connected to that? Now let's go to the route table. In this route table, what is given here? In the default route table, we have associated, right? Route table. What is this? Default route table. Default route table ID. And this is the main VPC, which will be created. And CIDR block. And this is the NAT gateway ID. AWS underscore NAT gateway, and ID. This is being added into the default route table. Now, NAT gateway has been added to the default route table. So in this default route table, now this particular security group, if I just go to the security group, right? Let's go to the security group here. Sorry, not this security group. I'm saying subnet. Routable NAT gateway created. IP elastic load balancer. Okay. So we have this NAT gateway created. What else left? We have this, let's see. We have this NAT gateway created with the C2 instances. We got this route table done. Then what we need access to the ALB, application load balancer, right? So if I just go here, we have this ALB, we have this ALB. So in this access load balancer, application load balancer, we have created one load balancer which will directly connect to the internet. Through internet will connect to the subnets. So here we have written a for loop to connect to this subnet. For, we already have discussed in the loop sections, right? For subnet in the AWS underscore subnet dot public. This is the public subnet, whatever we're getting, subnet.id. So it's getting added. And see, that's why, guys, as I said, to do automations, you should have familiar with application, how application load balancer works, right? So that you have to just go ahead and add it. Otherwise, it not understand clearly what is being the code written. So before doing this, just go ahead and have a look and learn these particular things, then only you understand. If I just explain, you will not at all understand anything. Okay, so for that, I'll just share you two videos to do it. One is manually, I have done how manually you have to set up all these things in the AWS, and the same things how we have to write in the Terraform code, same thing I have explained. These two videos I'll share with you. go and just watch these things, entire videos, and try to do yourself. I guarantee you, if you do all this project by yourself once or twice, then you'll be at least confident on your code on your automation side, right? So this is a task for you guys. Whatever I just explained you, because all this, if I explained now about this LB, you will not understand at all, because you have not done my AWS cloud session, right? Because in my normally whatever I have done, AWS cloud, both cloud and DevOps, I always complete the cloud part first and then come to the Terraform DevOps side. Okay, so because that's why I always keep the Terraform at the end of this class, so that I complete AWS completely manually, and then I just explain this Terraform stuff, so that it will be easy to understand the Terraform, because it is completely related to cloud work, cloud automation, right? So that you should first understand how the cloud works. I think Kishore can relate this thing, because he has completed the cloud class, so he'll understand good ways, right? I think Ibrahim, you also completed the cloud class, right?
Yes.
So you guys can understand this application load balancer. But still, if you have not brushed up, or if you have not remembered these things, I'll just share these 2 links with you. You can just go ahead and brush up your knowledge and just work on that. That's all, guys, for today's class. If you have any doubt, we can discuss, or else we can wind up. I'll share this session, this recorded sessions with you, and the videos also, right? So that you can just have a look on that.